Welcome to this deep dive into Spring Boot auto configuration. In this comprehensive technical guide, we will explore how Spring Boot automatically configures your application through the power of enable auto configuration, conditional logic, and intelligence bean detection. By the end of this session, you will understand exactly how Spring Boot transforms a simple Spring Boot application annotation into a fully configured application context ready for production. Core concepts. Auto configuration is the foundational feature that makes Spring Boot special. Rather than manually defining every bean in verbose XML files, Spring Boot intelligently registers infrastructure components like data source and dispatcher servlet based on what's on your class path, your existing beans, and your configuration properties. It follows the principle of convention over configuration, meaning you get sensible defaults that work out of the box while still maintaining complete control. This approach dramatically reduces boilerplate code and lets you focus on writing business logic instead of wrestling with the framework setup. Before Spring Boot, developers faced a significant challenge. You had to manually define every single bean in verbose XML configuration files, even for standard components like data source and transaction manager. This led to massive boilerplate code that was error prone and repetitive. Project bootstrapping could take days just to get the basic infrastructure wired correctly. Managing different configurations for development, testing, and production environments required complex profile setups. This result was lengthy XML files that obscured your actual business logic and made it difficult to get started with new projects quickly. The solution. Spring Boot solves these problems through four core principles. First, it provides plug and play starters, which are curated dependency bundles that simplify build configuration. Second, it uses smart auto detection to scan the class path and discover available libraries automatically. Third, it follows convention over configuration, reducing the number of decisions developers need to make. Fourth, it provides opinionated defaults that work for the majority of use cases out of the box. The benefits are immediate, easier customization, consistent setups across teams, significantly less boilerplate code, and faster development cycles. You can now bootstrap a production ready project in minutes instead of days. Spring Boot application entry point. The Spring Boot application annotation is your entry point to auto configuration. It's a convenience annotation that actually combines three separate annotations into one. Configuration marks your class as a source of bean definitions. Enable auto configuration triggers the actual auto configuration. This is where the magic happens. Component scan scans your own components such as controllers and services in the current package and its subpackages. This single annotation bootstraps your entire application context, automatically configuring all the infrastructure you need while also picking up your custom application components. Enable auto configuration mechanism. Enable auto configuration acts as the ignition key for Spring Boot's intelligence. When activated, it tells Spring Boot to begin the intelligent configuration process based on the contents of your class path. It uses a special component called AutoConfiguration.imports selector to find and load candidate configuration classes. Critically, it doesn't blindly create beans. Instead, it evaluates conditional rules to decide what should actually be activated. The process reads from a special file called AutoConfiguration.imports in the meta-inf/spring directory, which contains a list of all candidate auto configuration classes that Spring Boot can potentially activate based on your dependencies. Where auto config classes come from? Auto configuration classes aren't magic. They are regular Java classes packaged inside Spring Boot's own jars. The key is understanding where they come from. Spring Boot maintains a master list in a file called meta-inf/spring/org.springframework.boot AutoConfiguration.imports. This file, which replaced spring.factories in Spring Boot version 2.7 and later, contains references to over 100 auto-configuration classes. These classes handle everything from core framework setup to database support and web server configuration. When Spring Boot starts, it reads this file to identify which auto-configurations are available candidates and then evaluates their conditions to determine which ones should actually be activated. Auto-configuration loading flow. Spring Boot follows a deterministic and strict sequence during initialization. First comes the discovery phase, where Spring locates all candidate configuration classes from the AutoConfiguration.imports file. Next is the filtering phase, where it evaluates all the conditional rules on each candidate class. These rules check whether classes exist on the class path, whether properties are set, whether beans already exist, and other conditions. Finally comes the creation phase, where qualified beans are registered into the application context. This three-phase approach ensures that configuration happens in a predictable and inspectable manner that you can understand and debug. Conditional annotations overview. Spring Boot's intelligence comes from a set of conditional annotations that act as decision gates. @conditional on class checks whether a specified class is present on the class path. This is fundamental for starter-based auto-configuration. @conditional bean checks if a specified bean already exists, enabling the back-off logic where user-defined beans take precedence. @conditional on property checks environment properties and is useful for feature flags and environment-specific configurations. @conditional on web application ensures web-specific configurations only load in web applications, not batch jobs. There are also specialized conditions such as @conditional on resource and @conditional on Java. Together, these annotations create an if this then that logic that forms the heart of Spring Boot's intelligence. Decision logic, conditional evaluation. Let's trace how Spring Boot evaluates conditions for a configuration class. The process is sequential and deterministic. First, it checks whether required classes are on the class path using @conditional on class. Next, it checks whether required properties are enabled using @conditional on property. Then it checks whether a user-defined bean already exists using @conditional on missing bean. If a user-defined bean exists, Spring Boot immediately backs off and skips the auto-configuration. This back-off mechanism is crucial. It means Spring Boot respects your custom beans and never forces its defaults on you. If any condition fails at any step, the entire chain stops and that auto-configuration class is skipped. Real-world example, data source auto-configuration. Let's look at a concrete example, data source auto-configuration. This class is decorated with @conditional on class, which checks that the data source class from a JDBC driver is present on the class path. It also has @conditional on missing bean, meaning it only creates a data source if you haven't already defined one. If both conditions pass, Spring Boot automatically configures a database connection using Hikari CP and the properties you have set in application.properties. This smart approach means that if you include a database starter, you automatically get a configured connection pool. If you define your own data source bean, Spring Boot detects this and skips its default configuration, allowing your custom setup to take the precedence. Spring Boot starters. Spring Boot starters are convenience dependency bundles that aggregate related libraries and manage their versions automatically. They solve the jar help problem by curating compatible versions of libraries that work well together. When you add Spring Boot Starter Web, you implicitly include Spring MVC, Tomcat, Jackson, and other required frameworks. More importantly, you add the auto configuration classes associated with those frameworks onto your class path. Starters don't directly configure beans. Instead, they provide the conditions that trigger auto configuration. By adding a starter, you are essentially saying, I need this capability. And Spring Boot's conditional logic activates the appropriate configuration classes. Starter to auto-config flow. Here's the complete flow from starter to a working application. First, you add a dependency such as Spring Boot Starter Web to your pom.xml or build.grid. Second, Spring Boot scans the class path and detects all added libraries. Third, it reads the AutoConfiguration.imports file and evaluates the conditions for each AutoConfiguration class. It checks whether required classes are present, whether properties are enabled, and whether user-defined beans already exist. Fourth, all conditions that pass result in beans being created and added to the application context within seconds. If you have fully configured dispatcher servlet, data source, Jackson configuration, and everything else your application needs without writing a single configuration line. Application properties impact. The application.properties file is your primary control knob for auto configuration. Spring Boot reads these properties at startup and passes them to the auto configuration classes, which adapt their behavior accordingly. For example, setting server.port equal to 8081 triggers embedded web server factory customizer auto configuration to change the Tomcat port from the default 8080. Setting spring.datasource.url tells data source auto configuration to create a connection to MySQL instead of an in-memory H2 database. Spring.jpa properties are passed directly to Hibernate, controlling behavior such as schema updates. Properties can come from multiple sources, including property files, YAML files, environment variables, and command line arguments. This flexibility allows you to keep the same code across environments by simply changing configuration values. Auto configuration report. When things don't work as expected, Spring Boot provides powerful debugging tools setting debug equal to true in application.properties. Enables a detailed conditions evaluate report during startup. This report shows positive matches, the configuration classes that were successfully activated, and negative matches, the ones that were skipped and why. For each negative match, Spring Boot explains which condition failed, such as a missing class or a disabled property. Alternatively, you can use the Actuator conditions endpoint at runtime to retrieve the same information in a JSON format. This transparency ensures there is no black box. You can always understand exactly why Spring Boot made more specific configuration decisions. Excluding auto configuration. Sometimes Spring Boot's opinionated defaults don't fit for your requirements, and you need to opt out cleanly. There are two primary approaches. First is the annotation based approach, where you add exclude equal to data source auto configuration class to your @Spring Boot application annotation. This method is type safe and prevents class loading issues. Second is the property based approach, where you set spring.autoconfigure.exclude in your application.properties or application.yaml. This method is useful for environment specific exclusions. For example, you might exclude security auto configuration in development but enable it in production. The key principle is to exclude only what is necessary. Avoid disabling auto configuration entirely. Instead, remove only the specific configurations that conflict with your custom setup. Component scan versus auto configuration. It's important to distinguish between component scanning and auto configuration, as they serve different purposes. Component scanning discovers your application code, the classes annotated with @component, @service, @control. It is package driven and focuses on business logic. Auto configuration, on the other hand, focuses on technical infrastructure. It registers framework level services such as data source, dispatcher servlet, security filters, and messaging systems. Component scanning is explicit. You write the class and annotate it. Auto configuration is implicit and condition driven. Together they work seamlessly. Component scanning registers your business logic, while auto configuration supplies the infrastructure that your logic depends on. The backoff mechanism. The backoff mechanism is what makes Spring Boot polite and non-instructive. Every auto configuration classes uses @conditional on missing bean to check whether you have already defined a bean of a particular type. If you defined your own data source or security filter chain, Spring Boot detects this and enables its default auto configuration for that component. Your your custom bean always wins. The recommended strategy is to customize behavior using application.properties, as this covers most customization needs. Replace entire bean only when property based configuration is not sufficient. This philosophy ensures Spring Boot enhances productivity without locking you into its defaults. Let's clear up some common misconceptions about Spring Boot. First, auto configuration is not magic. It is deterministic logic driven by conditional evaluation. Once you understand conditional annotations, the behavior becomes predictable. Second, starters don't configure anything directly. They simply aggregate dependencies and place jars on the class path, which triggers auto configuration. Third, user defined beans always win. Spring Boot never overrides your beans. It backs off when it detects them. Fourth, the process is fully inspectable. With debug logs and actuator endpoints, there is no hidden black box, only transparent, understandable behavior. Some interview tips. In interviews, avoid saying Spring Boot just works or is magic. Instead, explain how enable auto configuration reads from the AutoConfiguration.imports file and uses conditional logic to load configuration classes. Emphasize the backoff mechanism provided by @conditional on missing bean, which ensures user-defined beans take precedence. Mention debugging tools such as debug equal to true and the actuator conditions endpoint to demonstrate real-world troubleshooting knowledge. Always explain the flow clearly. Starters and libraries to the class path. Spring Boot detects them, conditions are evaluated, and appropriate beans are created. Complete big picture architecture. Let's bring everything together. The process starts with dependencies on your class path. Starters introduce libraries such as Tomcat, Spring MVC, and Hikari CP. In the discovery phase, enable auto configuration loads candidate configurations from the AutoConfiguration.imports file. In the evaluation phase, all conditional checks are applied: class path presence, property values, and existing beans. If a user-defined bean is found, the auto configuration immediately backs off. In the final registration phase, all qualified beans are added to the application context. The end result is fully configured application where auto-configured infrastructure and custom business services coexist seamlessly. In short, Spring Boot auto configuration provides opinionated defaults that remove boilerplate and accelerate development. It is driven by context, specifically class path detection, configuration properties, and existing beans, not by magic. The entire process is fully inspectable through debug logs and actuator endpoints. Most importantly, it is easy to override. Defaults adapt when you change properties, and they back off completely when you define your own beans. Mastering auto configuration enables you to write cleaner code, debug issues confidently, and customize Spring Boot without fighting the framework. Thank you. Thank you for exploring Spring Boot auto configuration in depth. You now understand how Spring Boot transforms a single annotation into a fully configured application through intelligent conditional logic and class path scanning. You have seen that the magic is actually deterministic, inspectable code that always respects your customizations. With this knowledge, you can build more efficient Spring Boot applications, diagnose configurations issues quickly, and make informed decisions about when to rely on defaults and when to customize. Stay connected with at everything about Java for more deep dives into Java and Spring Boot. Happy coding!